Okay, my name is Milosz Wasilewski. I'm gonna present the session about LKFT, what we did so far, what we're planning to do, and in the second part of, so it's scheduled for 50 minutes. In the second, I hope to fill in about 25 with the presentation, and we have 25 minutes for discussion, questions, whatever there can be. So I'll present about the details of how LKFT works right now, some details about what problems we experienced in the early stages around 9 months ago, the plans for the future, and then we have time for Q&A. So LKFT stands for Linux kernel functional testing. That project was started a year ago in Budapest, in Connect in Budapest, with the assumptions that we will help Greg Kroll-Hartman to maintain LTS releases for a bit longer. And the assumptions we had internally was that we don't have too much hardware. The hardware resources are limited. We needed quick turnaround time, so Greg asks for a reply to his release candidates within 48 hours, so we probably have to get our results faster than that. And we should be avoiding false alarms, so sending email that something got broken when it didn't, or that there is a regression while there is no regression is a very bad thing to do. This is from Ryan. So how this picture shows how the system looks like. So we're launching the build on the push to the Git tree. Then our Jenkins launches builds for all the hardware that we have. Those builds are uploaded to snapshots, then we pick them from there and run test jobs on them using Lava. And then once all the test jobs are completed, the results get sent to our internal mailing list. So we tried sending those automatically to stable mailing list, but there was first too much details. And secondly, the number of false alarms was too high to be accepted in the upstream, I believe. So a quick round of numbers. So we're building several branches. We built Next, we built Mainline, we built LTS branches, which we currently have 3, and the current stable branch from kernel.org. We also built several branches from AOSP trees. These are usually stable branches. Currently 6 branches from kernel.org, 6 built for each branch because we have this many hardware variants, 20 test jobs per build, plus additional 20 for each architecture for QEMU, so additional 60, and roughly 13,000 tests executed for each build. For AOSP, it's slightly different because we're using different user space, the tests are packaged differently, and we have also a different set of tests. So we're using a subset of CTS that was identified by Google. So in the highest count scenario, we have around 50,000 test cases to execute on AOSP. All tests are built into, for OE-based testing, for our open embedded images, all tests are built into the root file system, so if there is a need for reproducing the problem or reproducing the failure, we can just do it. The file systems are a bit big, so a bit too big to be turned into RAM disks. They are 200 megs. A bit more than 200 megs, and some LTP tests, for example, they require 4 gigs of disks to run some for temporary files. The number of 20 test jobs, so we could probably execute just one test job, but Lava has its limitations, and we want to avoid losing test results in case something gets terribly bad. So in case we get a kernel crash or board freezes for some reason, we would lose all the remaining tests. So that's why we execute those in chunks on different, and this also helps to reduce the time to get the results back, because we have several boards. So that's one of the reasons as well. Now, as for the problems, there were the problems with test suite that we have. So not all tests are applicable to our setup. So LTP carries some tests that we don't run because there is no point in doing that. They don't bring any value. We run several tests, different test suites, and there is no common way among them to define which tests to run, which tests to skip, and that brings a bit of maintenance on our side. Output of the tests is not really automation friendly, so parsing those tests happens several times. Once in Lava, once we have, after Lava finishes, we have to do it again to get some output, some different things from the output. And as I mentioned, LTP tests are, I guess they were written with assumptions that they run on a powerful hardware with a lot of resources, a lot of disk, and that's sometimes not the case. In our case, this assumption is not met. For K-self-test, when we started, there were problems with getting all the configs right. So the tests were assuming that the configs are enabled while they were not. I guess this is already fixed, so the config fragments for tests were updated. Different architectures have different sets of tests, so there are architecture-specific tests in K-self-test. We decided to run the latest stable version of the version of K-self-test that comes from the latest stable kernel on the LTS branches. That was not always well received, so some maintainers of tests don't agree with our approach. They say that the K-self-test version has to match the kernel version that we run on, and they refuse to make fixes for the tests so that the tests detect the features. In these cases, we just skip those tests. Some tests require kernel command line parameters to be passed, and I think it was recently added the vsyscall test case. It can be run with 3 different parameters, and for that 3 different boots have to happen, and this requires, in our case, 3 different test jobs. And I think my biggest complaint about K-self-test is that there is no real enforcement of any style coding standards or reporting standards right now. With our lab, the problem that we faced in the early stages with our lab. So the boards that we're using require fastboot to be flashed, so we flash the system images using fastboot to the board, and we started by using the version of the fastboot that came from the distribution, from Ubuntu, which turned out to be too old, so there were issues with load on CPUs, load on I/O, and the solution for that was to update to the fastboot from the latest SDK. That hopefully fixes the problem for now. Then the second problem was that we frequently saw the board disconnect from the serial. It turned out to be the problem with the sonic screwdriver, the small mezzanine board for 96 boards. We switched to FTDI cables directly plugged into the header, and I guess that sort of made the issue gone, right, Dave? Thanks. Then, again, this didn't fix the problem entirely, and after a lot of debugging, I think it took us around 2 months to discover that the whole USB stack was reset by some problem that we couldn't fix, and Dave decided to change the cables, USB cables to shielded ones in the lab, and that made the issue go away. So I guess this is something that that can't be predicted by using using the board on your desk and then scaling up to the lab. Doesn't it can be predicted. This kind of problem can be predicted. As I mentioned, issues with getting the kernel configs right. So that's the previous slide. Then we had a problem with one of the LTP tests, and it was failing. When I ran the tests locally, it was passing. And it took a few days to figure out that systemd was giving different quotas for different users logged into the system. So again, some sort of a configuration problem. Lastly, there was a problem with high keyboards. So when running CPU freak test cases, the boards were overheating and rebooting. Turned out to be a problem with firmware and kernel, hopefully fixed now. As mentioned before, initially we hoped to get the reporting automated, so whenever Greg pushes his release candidate, we would get the testing done and the email automatically sent back with the test results saying, yeah, you have regression or not. This turned out to be not possible right now. We still get some level of false positives with our testing. We get a few broken builds due to the infrastructure, so we have to curate the reporting back to the upstream. The false positives, so whenever we change the version of the test, so change from one LTP release to another or change from one K self-test release to another, there are new tests added, and the tests added are not always great. So there is usually what happens is that the new tests fail, or with LTP there are a few failing tests that and it turns out that those are the ones that were added for various reasons. So it's sometimes that there is a missing dependency, or the test was for K self-test. The test was developed for x86, and it's not architecture specific, but it fails on ARM. So for those reasons, we can't automate the external reporting yet. I really do hope that we can get to the point that this will be possible. So we don't have to look after the results that much. Right. So for the future, the changes in the hardware in the lab, we hope to get a bit more hardware to test on. This would make the results, the turnaround time for getting the results faster. The second place for improvement is the coverage. And the reporting software, I guess I forgot reporting. The reporting software improvements, that's the third area of work. So for the hardware, right now we're using sort of a homegrown DIY setup for our boards. It takes a lot of space. There are a lot of points where things can go wrong, and they sometimes do. And in order to mitigate this problem, we started looking for a solution, for a hardware solution to pack more boards into our tight space in the racks in our lab, as well as reduce the number of cables required. sourcing the boards that we use became a problem. I learned recently that we will get a few more high keys, thanks to high silicon and LeMaker. So that's well and good. Yeah, so that's where the hardware goes. The big challenge is to preserve the stability. So, as I mentioned, we want to send the reports out automatically, so we don't want to get any false positives. Our current setup does not allow for that. So, for example, we get very rarely, but it sometimes happens that our test jobs fail because there is a demessage output that's interlaced with our test output, and we either miss a test or make lava job crash, or something bad happens. In order to avoid that, we would like to get a second UART console on all boards. For the boards that we have currently in the lab, it's possible. So yeah, we'll do it. This used to be a low priority, but I hope to get this done before the next Connect. In order to reduce or increase the chance of fixing the problems with failing test jobs, we need to speed up the turnaround time. So this is where more hardware comes handy. One more field to improve is that right now all the changes to the lab, to lab configuration, changes in the cables, in Lava software, they used to come directly to the production server, production lab. We recently set up the staging lab to check whether the changes somewhere in the lab make our test setup broken. So to give an example, there was a change in the UEFI firmware for high key, which made all our test jobs broken. So if that made its way to production, that would mean a downtime for our service. For the test coverage, there is an ongoing discussion what to do, which tests to add, whether to add any. We had a very good discussion with LTP maintainer Cyril Hrubis this week. He made a few suggestions which parts of LTP are underutilized in our setup, so we'll probably add those. There is an idea to add a device driver test from TI, a perf event test. There is a bit longer list, so yeah, I'm open to proposals. This will not happen overnight. It requires quite a big effort to make sure that the tests are actually passing. They give meaningful results, and there are no stability problems with them. For the existing tests, there are a few items that we would like to improve. Firstly, the logging. So unified logging is something that we really, really want. And there is some work ongoing for K-self-test to get the logging better there. Same applies to LTP. There was a discussion with Cyril how to make it better. There are a couple of ideas that we will try. Executing the tests, that's something that works right now, but it can be better. So currently, when we spot the test that breaks the board, crashes the kernel, makes it freeze, so makes it unresponsive for some reason, we have to skip it and disable it for the future execution. With this is because how our setup works. It can probably be improved, but it will require either making the setup more complex or changing the way the test execution works. So this is the area of experiment for the moment. I don't expect this to happen soon, but yeah, this is something that we will probably at least check. And again, we would like to preserve the stability here. So all the efforts go towards making sure that we don't, that we execute everything that we assumed and we don't break tests, break the results without the real reason, so that our infrastructure gives some problems. Finally, about the software that we use for testing, for executing tests, for reporting. So mainly our web UI. There were a lot of discussions this week and previously in the previous months what to make better. There are some good ideas how to improve the web UI navigation, how to improve the reporting in the emails as well as in the web UI. Some previously mentioned changes are required for improving the availability of the logs, availability of instruction to how to reproduce tests. So some infrastructure for this is already available. We're just missing some data. And one of the items that we've been working on for a couple months now is supporting bisection in case tests fail. This wasn't the highest priority, and I guess it still isn't because we don't get too many regressions. But yeah, this will be probably something handy. So the questions that I have is what should we put the most effort in? So what are the priorities that we should focus on? And the second is whether there is something missing, something that we didn't do so far, but we should have. And yeah, so that's where I guess we should start discussion. So that's all I had. Now I'm waiting for questions, comments, criticism.
So we have the same issues as you do from our distribution testing point of view, where we are trying to basically make sure that OpenSUSE runs stable. And the only CI we have there realistically today is in virtual machines using OpenQA, which means we have an existing workflow that works for us, but we cannot easily project that to real hardware because our real hardware testing with OpenQA runs using BMCs. Because of that, we are currently developing a board that might be interesting in this scope as well. You were mentioning that you had problems when your firmware changes because you're only plugging into your test infrastructure from a working firmware above, right? So basically you replace the kernel, you replace init.ds, you replace root file systems, but you don't modify anything below. And because our OpenSUSE images usually also contain firmware, that's exactly one issue we need to solve. And because of that, we're currently working on developing a board that allows you to do SD emulation and HDMI capturing and USB emulation to basically intercept all the inputs and outputs a device usually has that are volatile, that are non-volatile, and essentially make them volatile and changeable from the outside, so that you could just deploy a new image that directly gets pulled in from a server outside, which as a side effect means you don't destroy SD cards. Mm-hmm.
Yeah, did you see the MaxPy from Samsung, Tizen?
I saw it. We do not want to have a solution that involves manual labor, and you will destroy an SD card if you mux. Also, our images are usually a couple gigabytes, and you don't want to wait for 10 minutes until that image is flashed on the SD card and then mux back again. It just doesn't scale.
Okay.
So
yeah,
that's
in our case, the images are slightly smaller, and the SD card is something that you can easily replace, contrary to eMMC that we have on board.
If you have 1 or 10, yes. If you have 100, no. It's a matter of scale, really. It matters just how many of those systems do you want to have automatically tested, and how many side effects do you really want to evade. SD cards will get slower. They will potentially just lose data once they fill up. You will run into bugs. You will run into bugs with eMMCs as well that just have a broken FTL layer somewhere. That's all things you don't want to test in your test infrastructure. Those are things that the hardware guys should test, not things you want to test. So, but that's a completely different story. What I would like to invite you and everyone is to basically give me feedback. We're currently in the schematic design phase still for that system. So anything that you need to have intercepted, that you need to have monitored, that you need to have captured to make those systems useful for you, I would love to hear feedback on that.
Yeah, I guess you capture what I think we have similar case with HDMI outputs on the right. Yeah.
The question was if I heard of Chameleon. Yes, I heard of Chameleon. Chameleon has a couple of different issues. For starters, it only does HDMI and not the other parts. You could extend the base Altera board with that, but it's hard. Well, it's not hard, but it doesn't scale well. It's slightly too expensive. The whole overall setup is slightly too expensive to actually scale to a full lab equipment. For us, for Google, it probably doesn't matter. They just throw money at things, but we can't. It doesn't actually capture HDMI. It only checks HDMI. So it only does checksum verification on pictures. It doesn't do full image capture. And the way our QA process works is not by checking whether the image that comes out is exactly the image we want. It's by verifying whether parts of the image are exactly the parts we want. So for example, we open an Xterm in your GNOME environment and then just capture, like we're searching for we call them needles, for a small piece of graphical output and just check whether that's available on the screen somewhere. Because we don't care if your Xterm opens 5 pixels to the left. Whereas if you do a checksum approach, that would fail. If you're doing a needle-based approach, that one works. Right. We also have a bit of fuzziness in there because we also added support for things like VGA input back in the day. So you could say, I only want a 90% accuracy. But yes, so basically, if you do have ideas on things you need to have captured, I know of UART, I know of HDMI, I know of USB, I know of relays for switching on and off buttons, for switching, for passing through power, for measuring power, but maybe you do have more ideas. The whole project description is on the OpenSUSE wiki, and it's called Calamari, like calamari with lots of octopus arms, but doing CI, so that's why it's Calamari. So CILAMARI. Just search for that. You see the list of things that are currently on there that we want to have built into the product. But
do you have any estimate when are you planning to finish this project or make it available?
So the current timeline is to have a first prototype board available this autumn.
This autumn.
It's the first prototype board, which means you will. I mean, if things go well, and you never know that when you're doing hardware.
Okay.
It might be next year.
Thanks.
So for the problem about having the kernel messages mess the serial console, I saw that some other people have had the same problem, and the solution was to send your own messages via dev KMSG, which then gives them to kernel to output in the same way it outputs its own error messages, so they get nicely interleaved instead of messed up.
Yeah, but that boils down to how the tests log their output, right?
Yeah, but they are open source, so you can change them, right?
Yeah.
So there is actually a patch up for Lava to start putting the Lava signals into K-message to try and get around this. I'm testing it right now. It's actually.
Oh. Okay, it's back, I hope. Yes. So, yeah. But you have to have all the messages in the K message, right? Not only the Lava. Yeah, but if the test output messes with the K message, then you get the same effect.
No, because we're relying on kernel to do the buffering so we get full lines.
Yeah, but test output doesn't rely on that. So it's the same problem,
yeah.
but reversed.
Print K doesn't respect serialization. The print K print K runs in a kernel process, and during the middle of the, let's say during the middle of a writing of a line, if the kernel process takes over, print K's message, it goes right into the buffer, as far as I understand.
Yeah, but
So the idea here is to redirect the standard output of the init process to def KMSG, which turns every single write into a print K.
yeah,
And then the print Ks are sorted with regards to one another.
and then you get everything through print K.
Ah, that's perfect.
Yeah. Yeah, we can try that, I guess.
That also gives you timestamps on each output.
Better.
Not sure that helps, but yeah, we can try that.
It helps analyze things. It doesn't help you run things, but when you look at the logs later to find out what went wrong, you can see when things happened.
Mm. Okay. Any other suggestions, questions? Not, then we can probably go to lunch. Vishal?
The email reports, the problem with email reports currently, which I see is, they send a mail saying there's no regression with partial results,
Yeah.
and later with full results, we'll get another email. That is
Yeah, that's a
something-
bug. That's a bug, and,
Yeah.
this is very high on the to fix list. And I also suffer from that a lot. Yeah, I know.
So just going back to the commentary on SD cards and SD muxes, we've been using SD cards, rewriting SD cards for 7 years in the Lava lab. We do see occasional degradation of the SD card, but it's nowhere near as bad as people predicted it would be.
Mm.
We're not using we picked the right SD cards to start with, right?
Yeah, we pay. As with everything in the lab, we've discovered if you buy the more expensive, the more likely you are to have success.
Yeah, well, you don't have the SD Max yet.
No, but we
Anyway,
don't.
so,
But we've had 2 attempts at it. But
Okay. So I guess that's all. Thank you very much.